Welcome to the presentation of the paper Iranian wheat varieties classification by using a fusion of texture features from Andre and Mostafa. Well, wheat is one of the most important strategic agricultural products, and we have different varieties based on region and climatic conditions. In our paper, we are working with Northwest Iran, so here are some statistics about production in Iran. Challenges with variety classification. We have the traditional methods, that expert-based methods are slow, inaccurate, dependent on the person that's performing. So have the issues like fatigue, decision making by the person evaluating, low control. So we have some needs for a non-destructive method to speed up the process and accuracy. One way is to use texture analysis, and texture refers to the appearance of an area or surface, how this surface interacts with light. So it's a powerful discriminator in images, have several applications, we have many methods that represent the texture based on different approaches. So we have textures that are regular, near regular, irregular, near stochastic or stochastic. So we have different methods focusing on each type or characteristics of these textures patterns. And we have many applications for texture analysis, from edge detection to pattern recognition, to segment regions with similar characteristics, filter noise, identify patterns, and improve the information extraction. Our proposal in this work is to explore different texture analysis methods and their combination, to classify with images. For this, we use the data set that contain some varieties of wheat, in this case these ones, and this sample were collected by Iranian Agricultural Research Institute from Iran. The dataset it's like that, some images of wheat varieties. They are have a black background, and was removed, and the remaining image it was cropped into non-overlap sample. So we have here an example of the texture patterns that we are using for each class of wheat. So here we have 7 classes. Each class is a wheat variety. Each class has 5 samples, this one, and 9 non-overlapping sub-images. So total we have 3,150 sub-images or batches. Each one with 200 pixel size. We extract the features, texture features from these batches. So we have a lot of texture features in literature. They cover a wide range of applications. We choose some of them based on effectiveness in literature. Some of those are more common, like LBP, JDM, DCT, Fourier. Others are more recent, like joint adaptive medium binary patterns. So are based on complex analysis like fractal and linearity. To perform feature extraction, we discard color information. Most of these methods are work only on grayscale images. Some of them extract a fixed number of features, like first order. They are computed from the histograms. We computed 5 descriptors. Others, they depend. There is a configuration where you can achieve maximum accuracy. So we set up the method to best configuration possible. So we have 34 methods. We wish to combine them to improve accuracy of classification. Try and error is impossible. We have 2 raised to 34 combinations. Best solution for us is to use a bio-inspired algorithm to search for the optimal solution. so have fewer parameters is easy to perform. We use particle swarm optimization for this case. The inspiration of this method is behavior of flocks of birds, schools of fishes. So we have particles that imitate group movement, and they combine solution while search for a global optimum. Okay. In this work, we use the particle swarm in two cases. Best combination of methods. So we have 34 methods, and we have to select the best combination. The other approach was the best combination of features. So we get all features from all methods and select the best ones. So we're not using all features from a method, but the best feature from method 1 with the best feature from method 2, and combine the features. How do we select? We consider each method or feature as a position, as this x in the position in search space. D is the number of dimensions, which could be methods or features. And particle swarm will be executed. After it achieves best solution, we will select methods or features where x is higher than 0.5. Okay. Fitness is the accuracy of the selected combination. So we are selecting here the methods that offer features that achieve 0.5 or higher to combine during the classification. Okay. We evaluated 3 classifiers, or KNN, nearest neighbors, which selected the best class based on proximity and a voting scheme. Okay, we used the standard features, so applied z-score before. We used the k equals 1. We used LDA, which is a statistical classifier based on Bayes theorem. Okay, and then he works by finding a linear combination of features that maximize class separation. So this is the idea. And he uses support vector machine. It's also looks for hyperplanes that best separate the samples while try to maximize this margin of separation of the samples. Okay. We use linear SVM with default parameters. Okay. Results. First, we evaluate each method separately. So we have that KNN and SVM achieved best results with the joint adaptive medium binary patterns method. LDA achieved best combination with the concatenation of Iranian descriptors here. And we see that it's a much better result than other 2 classifiers. Worst results was with fractal error as radius methods for all methods. All methods were really bad with this. All classifiers was really bad with this method. Okay. Oops. A comparison. Okay. If you look for the classifiers, the feature nature impacts the accuracy. We see that they select best methods differently. Varies by feature. KNN has inferior performance overall for all texture methods. If you compare LDA and SVM, LDA perform better in most of cases, while SVM performs better in only 9 texture methods. In average, LDA outperforms SVM by 5.74%. Okay, and SVM outperforms LDA by a small margin. Okay. Second experiment, we try to combine the methods using particle swarm. So here we have the combination of methods. So the method is selected by KNN, LDA, SVM. Combination improves results. Okay, and you can see by that. Selection of methods is different by each classifier. So LDA selects much less methods than KNN and SVM. Only 2 methods selected by our classifier. That was the LBDF, LB plus FD, and fractal color Minkowski. Okay, most of the methods are chosen by one classifier or another, but not by the 3 classifiers. So the classifiers focus on different features. Improvement in accuracy by combining methods. So KNN has the best improvement, LDA the smallest. He already had the higher accuracy, so it's harder to improve this. Even though LDA performed better with fewer selected methods. We have a minimum overlap among classifiers. Okay. That's because the LDA selected much less methods. Okay. KNN and SVM, they have 11 methods in common. Okay, so there's a big intersection between the 2. But this result confirms that the combining methods improves accuracy. So instead of getting all features from a method, let's select is just best features overall. Features combination, minimum improvement. So the accuracy improvement is less than 1% across all classifiers. Okay, don't have much improvement. KNN and CVM, okay, improved it a little, but they have to select almost 50% of all features, and they are still inferior to LDA. Best result, again, LDA has a high accuracy with a minimal feature set, and selecting only features, he was able to achieve a high accuracy with only 10% of the features. Okay. So selecting features, it's a little more difficult because the particle swarm has more dimensions. So it takes a little more time to select the features, and has marginal improvement. Okay, so it doesn't worth the effort. In terms of classifier efficiency, LDA is highly efficient, using less features, best results. Okay, and KNN and SVM, they require larger feature sets to get a competitive accuracy. So we show in this work that with varieties classification is possible using text analysis. We are able to achieve a high accuracy with a minimum set of features, and that combining texture features using PSO, the particle swarm, it improves classification accuracy in both approaches, selecting methods and selecting features. And thank you for watching.